Okay, this is the video where we actually do a coil and show how the little tester works, the Q meter. What I've done, we've made the oscillator in the first step of building the Q meter. Then we built the buffer amplifier inside of it, and that brought us up to this complete circuit, the oscillator, buffer amplifier. And then the last stage, we added the voltmeter part of it and the detector part of the circuit. And this is what we have. All done, ready to go. So now what I'm going to do, I don't know if I can, need something here to prop this up on. Let's see, maybe, okay, maybe that'll work. Oh, wants to be lopsided. That'll make it work. Maybe. Okay, you see the frequency counter there. Alright, so we'll turn the power on. Let the tubes warm up here. Now I've preset the frequency. The test frequency is 7 megacycles. That's the target frequency that I want to wind the coil for. So there's just a little over 7 megacycles. Now we can turn up the gain of the meter just a little bit. And there's a variable capacitor across it. I'll show you more about that in just a second. As you tune it across the coil, we bring that coil into resonance. Then, I'm not sure if the camera picks it up, but I've made little marks on here. I've had the capacitor totally unhooked. I used a cap meter, and so I've marked it. The minimum is 8 picofarad, 25 picofarad, 50 picofarad, 75, 100 picofarad, and max on the capacitor is 140. And it looks like we're, get it down here, we're right at 50 picofarad across the coil. And I'll turn it down here where you can see the coil is actually right here. I've got it soldered to a little tie point. This coil is no ferrite core. It's a little cardboard tube, roughly 30 gauge wire, and there's about 45 to 50 turns on there, and that gives us a resonance with capacitance across this of 50 picofarad. And the coil diameter is 1/4 inch. So about 45 turns, 30 gauge wire, 1/4 inch diameter form, and 50 picofarads parallel capacitance. Resonates out at about 7 megacycles. Now if I wanted to test another coil, just shut the power off, unsolder this, and I have another variety of coils that I could put in here and check, like so. You can even use different diameters. It's just I happen to have 1/4 inch available. One word on the diameter, if you say use 5/16 wooden dowel, that would work. You could just cut a small length of dowel, drill a little 1/16 inch diameter hole through the dowel, and that'll give you a place to put the wires through to hold them in place. You could use larger, but 5/16 is pretty convenient, and you would use about 25% less turns. So obviously that would be, if we had about a 50 turn coil, we could just throw on 40 turns and see where we're going. If we're high or low, we could just simply either add or remove turns. But probably a dowel would be the easiest thing to come by these days. Old equipment, old military equipment, used to be full of these kind of little coils. These are kind of inconvenient because you have to drill a hole, get it real precise, and they've got a little wing on each side that presses through the hole, and then the wing expands and holds itself in the hole. The better ones, I don't have one I can grab right now, they have a little ring nut on the end. There's a threaded portion, and usually they're a 1/4 inch diameter. You just push the threaded portion through a hole and then put the nut on the outside, and the nut holds it and locks it in place. Those are easier to work with, but whatever you get a hold of will work just fine. Wooden dowel I've used a lot of, and that's about probably the most and cheapest coil form. It's not convenient in the fact that you can't tune the coil with a slug, but on these I've either got the slug removed totally, like this one, there's no slug in that one, or I've got the slug run all the way to the end so it doesn't really affect the coil. Okay, the test equipment you're going to find really handy if you don't have one yet is this little frequency counter. I talked about it in one of my earlier videos, and I keep forgetting to put a link. I will try to do that this time. These are only I think I paid $16.88. It comes with a little case, little Lexan plastic box that it fits in, and it's really a slick little counter. Plus, when you get done, it's programmable, and it gives you a way to offset the actual count displayed for a 455 kc plus or minus offset. So the circuit actually figures out and either subtracts or adds 455 or whatever your IF frequency is, and just makes it easier to you know, if you want to use this for a display on a receiver, you just tag this into the local oscillator, and on a single conversion receiver, this with the 455 offset would give the received frequency. So you don't have to figure out, you know, where you're at. You could just dial it and it would show your receiver frequency. Okay, I've got some other things to talk about. I've done some experimenting on the 28 volt, operating some tubes on 28 volts. And I've got a little deal here that I'll come back here in just the second half of this video and show you. So let me switch things up here and hook up another little rig, and I'll be right back.